Hey, Allah. Be right back.
Hello, I'm back, Lee.
Hi, Allah. Hey, yeah, I could hear you a second ago. Hey, there he is. All right. Nice.
Hello,
Thank you. Yeah.
I'm
Hey.
back
Hey.
with some beer.
Oh, nice. Hey,
How are you doing?
how come your beard doesn't have more white in it? What's going on? I'm starting to feel bad here. What's
I see. You are welcome.
yeah, thanks. Well, Ashish is on the call. He's got color in his beard too. So I'm kind of the odd man out here. It's not
Yeah, the old wise man.
good. Yeah. 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 Let's just call it that. That's good. That's good. Oh, good. So we got Mario is on, Pranav is on, and maybe we'll just take a couple of minutes to try to get organized just before we kick off the call in case a couple of others join. So that means we have a couple of minutes just to say hi to Allah. Actually, so Allah, I'm saying your first name right? It's Allah.
Yeah, yeah, that's right.
Yeah, man. You would think with only 3 letters in your name that people wouldn't ask you how to pronounce it, but
Actually, it's Aladdin, Aladdin. But to make it easier for people, just call me Allah.
oh, nice. Okay, I got you. Um, hey, to break the ice even further beyond making fun of my beard, let's let me ask you this. Um, or say a bit about yourself, if you would, just in terms of your level of comfort with Kubernetes and um,
Yeah. So actually, a couple of months ago, I joined the community, and they attended some meetings with them, some of the weekly meetings. Then I had some like like I did a career mistake, and then now I'm back to business again. So my background is I'm coming from networking to system administrations, and my level to Kubernetes, I have like 4 months experience with Kubernetes, and now I'm preparing my CKA. So in terms of deploying clusters, I have done that a couple of times on cloud basis VMs. I never have did it this in bare metal, but in VMs I have did it multiple times. So as I mentioned in my reply in this issue, I could be a good backup for the more experienced people here. So I have a good understanding too of DNS, IP, networking, and so on. And Linux, I'm very familiar with it. Like I can troubleshoot the logs, read logs, install packages. If there is any dependency issue, I can work through it and find out. That's me.
nice. Yeah, that's great. Yeah. That's all of you in a nutshell. Like that. That's all there is to.
Yeah,
No, no.
yeah,
Uh, that's wonderful. I'm glad that you're here. This is nice. As a matter of fact, I'm glad that there aren't 45 other people here because there's enough for there's enough work to be done for a handful of people to get into, but oh man, if everybody showed up, it would be a little tough. So that's great. Hey, hey, kudos on starting off with networking, man. Solid. That's a great place to have kind of have your initial focus, networking and Linux sysadmin. That's extremely useful knowledge, both of those areas. And yeah, I've been so used to deploying with a Minikube or a Docker desktop that I tend to forget, oh my gosh, how how bespoke a handcrafted Kubernetes or a deployment of any piece of software can be. And Kubernetes is no different in terms of the level of choice you have around what CNI provider you're going to have, what DNS, like just a multitude of.
yeah,
And so something that we've been so part of our overarching goal, and I think we're ready to kind of get rolling on the meeting. Um, just real quick, Abhi or Pranav or Mario, do you guys see other people in the Slack maybe asking around about where to join? Maybe we should just send a reminder to everybody that it's happening. If one of you doesn't mind sending a message or two in Slack to let people know.
Let me do it.
Thank you. Perfect. So this is for Ala, but also for the rest of us to kind of be on the same page. So so gentlemen, we're on a mission to see if we can provide essentially the CNCF playground, or the cloud native playground, or the Meshery playground. And hopefully those become synonymous, to the extent that Meshery as a piece of management software allows people to configure, deploy, and manage the ongoing life cycle of all of the CNCF projects. So basically anything that runs on Kubernetes, it hopefully lets you manage pretty well. In order for us to expose that capability to people to come and learn and explore all the different CNCF projects, we need to run we need to get serious about running an instance of this playground, a demo environment, a playground environment. One of the inherent challenges to any sandbox or to running anything is people purposefully or accidentally abusing it. Somebody might want to come over and mine some Bitcoin or run some things. If they can, in the demo environment, they can go do some stuff. They might be doing it on purpose. They might be doing it on accident. But as we look to run this in an open way, the damage that people can do is, well, it's only to the extent of these two bare metal systems. And the bare metal systems that we have are running in the CNCF labs, which is, well, it used to be Packet. They were acquired by Equinix. So there's this Equinix portal that we're looking at here. There's a CLI for interacting with the Equinix API. So there's a CLI called Metal, because it's Equinix Metal is the name of their offering. You can use a CLI to spin up and spin down bare metal systems. And that sounds kind of weird, to spin up and spin down, but anyway, to spin up and spin down bare metal systems, to install OSs of your choice, to pick different sized physical servers in different locations and all that. And so we'll get into that a little bit more. But one of the considerations that I think that we can get maybe into somewhat headlong, is because Ala is here, is some of the ongoing operational considerations of really any Kubernetes cluster and things that are running on it. Is like, Meshery as the primary workload. Is Meshery healthy? Did it fall over? How do you monitor Meshery? How do you tell that it's healthy? Some of that can be answered just in a very Kubernetes generic way. Nothing specific to Meshery necessarily. Just, is the pod up, or is the, like, there's a lot of that kind of a thing that we don't have. If you go to the Meshery docs, like, it's more or less absent of kind of all of that stuff. We don't need to write a manual on how to do generic Kubernetes workload, availability, monitoring and things. But we do need to highlight special considerations that people have for Meshery as an app. Like, does it expose a Prometheus interface? Does it emit logs? Those types of things. We need to, part of this, the start of this effort, some of the artifacts that will be produced would be SRE type artifacts, or recommendations that the project will have to Meshery users. So how do you do it in an HA way, and just Yep. So we have these two bare metal systems. We'd like to make sure that there's a Meshery deployment that runs in a 2-node Kubernetes cluster, that that we schedule workloads to the control plane as well as to the worker nodes, because it's just 2 nodes. So we shouldn't just waste one only running a control plane. We'll need to pick a load balancer as we go to expose the service. We need a load balancer that works on, we're in a metal environment, or that we can't rely on a cloud provider's load balancer integration. So we need to choose Envoy or something, provide our own Contour or Nginx or something. And, go over, so each of those areas just need consideration. Like, so there's a public IPv4 address that's assigned to this particular server, to each of the systems. Okay. Well, great. Then maybe we need how do we expose Meshery Kubernetes service, and then just go make a DNS entry for the project? So those are all, like, there's just a myriad of these, like, deployment considerations that we need to go through.
So should I start?
Yeah, please.
Okay, so just to give a brief, although Lee covered most of the stuff, we have this playground.meshery.io running right now, and currently this is running inside of AKS, which is a managed Kubernetes service. And so basically the ontology for this thing is pretty straightforward. We have an ingress pod running, which serves the requests for Meshery, and we have gotten these 2 Okinox bare metal servers, and we are in the process of migrating to this thing. So as of now, the current status is so first of all, here was the issue that was created, and I think you're all already familiar with the issue, so I don't need to go over what the issue was. And the issue also referenced this Meshery SMP action. And this, if you'll go over to this action, you'll click on actions, you'll find these tests running. And these tests are actually running on if you look at all these tests, these are running on the servers provided by Equinix. So the first 2 things that you're seeing, these are the newly created servers, which would be used for deploying Kubernetes. All the other ones over here, these are used for load testing in Meshery SMP action. So if you need to find out a way to interact with the Equinox API in order to do things like kill a server or do something like that, you can go over to this particular you can come over here, and you'll find inside of like mesheryctl.sh, these inside of these scripts, this is a good like a template for how to tear down these servers using the API. We are not using their CLI inside of the scripts. We are using their API using tokens and all. But as the discussion progresses, we'll reach a point where part of the discussion would be, do we need to tear down the whole server, or do we need to do a cluster cleanup? So with that, what's the current state of this whole thing right now? So currently, as you can see, that there are so there are 2 nodes right now. This 02 node is currently the master node, and the 01 is the worker node right now. And currently, this is the state of the whole cluster. So nothing but a simple Nginx deployment is present right now. The CNI being used is Cube Flannel right now, because it had only one YAML file. It is pretty straightforward to deploy. And usually you only deploy CNI on the control plane. You don't need to do it on the data plane. But when you use Cube ADM join to join your worker node with the other node, the basically the CNI knows how to make all that connection. So yeah, this flannel is being used as a CNI. To give even more context for running the containers, container D is being used. Although Docker is installed in both of these machines, Docker is not being used as a method of creating the containers using that, implementing that CRI interface, because before the 1.20 version of Kubernetes, that was the preferred way. But now the preferred way is to use container D or something like Cryo. So we are using that. And I'm telling all this because this is part of the debugging process. When you start up the cluster using kubeadm init, and then you join your worker node using kubeadm join, there are places where you would need to debug stuff. So you would use systemctl to look at the daemon things that are running. So for example, I am right now in the root node, and I can look at the status of I can look at the status of container D. So things like container D should be running fine. So if there is an issue with container D, if there is an issue with kubelet, if there is an issue with all of these things, we would run into a problem. So for those who don't already have this context, what kubeadm does is it starts, basically it requires you to have CNI already installed. It doesn't provide you the CNI. It does not provide you the kubelet. You need to have a kubelet already there. All it does is that it uses the concept of static pods. So when you use Kube ADM, it installs some static pods like etcd or Kube API server, the things required to start up Kubernetes inside of /etc/some directory. And then it asks kubelet to use those to run those pods basically. And once those pods come up, and because when you do thing like Kube ADM init, you provide the, so this, all of this is, mostly this is covered inside of the doc that was provided in this particular issue. So if you'll go inside of this thing, and if you'll click on the Kubernetes in bare metal in 10 minutes, this goes over a very basic procedure. So if you were to follow all these steps inside of, by after doing SSH into both of these servers, you would be able to successfully deploy Kubernetes across both of those servers. The only caveat in our case was that basically container D was failing over, and the reason for that was, I think I haven't sent out that thing. I will paste another link in that particular issue. Basically, the issue was that there was some problem with the configuration of container D. So as I said, that using systemctl to figure out if container D is healthy, if kubelet is healthy, these things, like, so for example, if I go back here, if anything fails over inside of the cluster, if containers are not coming up, so the first place to go would be to do systemctl status with, let's say, kubelet. So kubelet should be working fine. And in our case, the kubelet was working fine, the container D wasn't. And there was one part of the documentation that I had missed. So that was that. So now going from here, what's the next step? So the next step is to deploy Meshery. So how to deploy Meshery? So there are two things right now. First, to deploy Meshery, and then to deploy it using some sort of a GitHub action, or maybe an Argo controller, which will watches at the container registry, the OCI registry where we push our Docker images. And as a Meshery release is made, the way GitHub Actions work right now, they push a Meshery release image inside of that repo, and Argo can watch for those images, and based on that, it can be triggered to basically do because by default Kubernetes has that rolling upgrade. So we can run 4 to 5 or maybe 10 replicas, because we have 2 clusters, so it would be evenly distributed, maybe like 5 pods over on the node A and 5 pods over on the node B. And when whatever we use, whether we use GitHub action or whether we use the other some kind of a CI/CD stuff like Argo, the final goal should be to have this kind of a high availability, so that we can have this upgrade with no downtime. So yeah, so that's the second part of the discussion. Okay, so yeah, that's what we would discuss. And the part about networking, we would be, I mean, I would suggest that we would use Metal LB, which is usually used on the bare metal servers. So what we would need to do is we would need to allocate some elastic IPs, some extra IPs, and create a metal LB configuration. So once we have these public IPs, we would be able to go inside of this like any of the nodes, and if you do if config or maybe IP route show. So right now, if I look at what are all the network interfaces and IPs available on those. So as you can see, right now this is the public IP that is now currently exposed. We would need we wouldn't be exposing Meshery through the same public IP. This is the IP that we use to access the Kubernetes API server. So we won't want to use the same IP, of course. So we would be having another IP, an elastic IP, or maybe again that's part of the discussion. There are other network interfaces here as well, and here is the flannel one, which is used to make sure that basically, which is used for the CNI purposes. So coming back, we would need to have another public IP, and using whatever public IP that we create, whether this is static or whether this is subject to change. I think this should be static because otherwise we would need to have another workflow which makes sure that whenever the IP changes over here, the metal LB configuration changes. So we would need to create an IP over here, and based on this IP, we would need to create a metal LB configuration, and then metal LB controller will be deployed, which would make sure that whenever we create a Meshery service of the type load balancer, it is automatically assigned an IP within a CIDR, and that we would make sure that that CIDR that we provide over there inside of metal LB, basically the IP within that CIDR is available over here. So we already have given it an IP which it can expose to the outside world. So that would be the part of networking. And about the rollouts and thing, again, we can use GitHub Actions or we can use Argo, depending upon what is most convenient. So that is all I had to say as of now. If you have any questions regarding whatever I said, doubts at any places, you can ask.
Yep. So Ashish, there's a number of folks on the call, some who are here to out of interest, because here to learn and kind of be a fly on the wall, so to speak, and that's wonderful. There are a few others that are here to get their fingers dirty, to get their hands onto something. We were just getting to know Ala a second ago. I wonder if, I wonder how we start to break out some of these tasks. One of the open questions for me is in part not having familiarity with Equinix Metal and this last subject that you were talking about on public IPs and more or less like networking. Like how are we? Is it reasonable for us to expect that we can just expose any new service behind that on any port that we want to? And how are we going to deal with like Let's Encrypt or certificates? And there's a set of considerations around that.
Yeah, so once we have an IP from here, and we can use like once we have an IP over here and there is a running deployment of Meshery, which exposes that thing as a service, then we can start a Let's Encrypt thing, and it will do the verification on its own, and with whatever domain name we would have added. And I think we should make sure that that IP doesn't change, and I think we can do that over here. That IP is attached to that machine only. So we would need actually we would only need one IP for one node, and not we wouldn't need new two public IPs for two nodes, because Kubernetes networking internally would handle the traffic between the two nodes. We would only need to make sure that traffic can reach one node, which can be master node, which can be depending upon where we want to have that ingress of traffic at the first place. So yeah, so we so we can like when we go to create a request IP address over here, I think we can first create an IP over here and then come back to the bare metals. Wait a second. Oh, IPs. So I guess when we add more IPs, we can get the IPs from over here, and then make sure that, because once we add IPs over here on each node, then inside of here we would be able to, basically the traffic would be able to reach inside of the one of the nodes. So uh, once, like, we would need to just make sure that it can reach one node, and basically this, when we create Meshery service as a load balancer type, whatever the external IP is, that external IP will match the IP that will be provided over here, and that IP would be pointing to one of the nodes, so the traffic would be served from there.
Yeah.
Yeah,
So
I
there's,
think in the current deployment of Playground right now, we were running into a bunch of issues with Cert Manager. So we are not using Cert Manager, but I think in this case, we should use Cert Manager. Because it was a managed Kubernetes service, I couldn't debug a lot because the whole, everything works, everything is packed inside of a single binary and not exposed for us to debug. So this is one advantage that we get if we are not using a managed Kubernetes service and having a bare metal thing, that we have a lot more control over what we can or cannot do.
yeah, as a nice to have, right? Like, because what value does Cert Manager provide
It
primarily?
makes sure, it primarily makes sure that so for example, right now every 60 days these certificates are expired or something, right? So it makes sure that after 30 days or something, so there is a certain time period after which it sends out basically it sends out an issuance request, which makes sure that the whole flow which was used to create
It
that
does,
certificate
yeah.
is,
It is life cycle management of certificates.
it's
Yeah.
life cycle management.
It's
Yeah.
all I was trying to say is that it should be a nice to have. That, like, if we go to deploy it and we have any challenge, then we should just, in about 1 minute, generate a static cert that expires after a year and then list it and then come back to it. It would be good for us to have it, like you said.
Yeah. Again, yes, if we don't run into any issues, which I'm hoping that we wouldn't in this case.
So do we, I'll try to help with itemizing part of the tasks. So what we want to do is like break down these tasks and understand them, and then understand if individuals are picking them up, prioritize them, and understand who might take them on. Do we want to
Ashish, I
maybe?
have a question here.
Yeah.
Yeah, do we have any like high level, low level design document or something that we can pick up all the components together, and so we can understand where to put the service, the load balancers, and how to expose things. And when we
Yeah.
forget something, we can just go back to the high level design to see
Yeah, so there's a Meshery architecture deck which talks about, this is the Meshery architecture deck. We can look at how, like, all Meshery's components and how they interact with each other in different deployment models. So let me just paste the link over in the chat. The other thing that
yeah.
you might find helpful as is if you'll go inside of looking at a Helm chart basically gives you a lot of information about what is deployed and all that thing. So if you'll go into the install directory in Meshery inside of Kubernetes Helm, you'd find that we have two charts, Meshery operator and Meshery. So usually Meshery, when you install Meshery and when you connect to Meshery, it automatically installs Meshery operator. So we would be installing Meshery with just Meshery. Meshery operator would be installed by Meshery server automatically. So this is the, so here in values.yaml, you can look at what are all the things that are installed by Meshery, and eventually this is the Helm chart that we would use to to basically to install Meshery in the cluster. And there are other components as well, like we have adapters, and all of these adapters are optional. So when you do a Meshery deployment, you can pass on, you can change your Helm chart values.yaml or using flags or any which way to make sure that certain pods don't come up or certain adapters don't come up. So ideally, we would want all the adapters inside of this particular deployment. So, and the vanilla Helm chart installation where the default is, I guess, true, like enabled is true for most of these adapters. So we would just spin up a Meshery server with all of these adapters enabled as true. In using this Helm chart would make sure that everything like a service account, which is required by Meshery in order to be able to communicate to Kube API, everything is packed inside of this Helm chart. So let me put the link to the Helm chart as well.
Shouldn't we adapt this topology to like a draw IO something to be custom with the new server deployment?
Come again?
I said like if we take the Meshery architecture and we make yes this one, and we make it with the custom changes that we will do in the bare metal servers, like here if we see this topology, where is the service type load balancer here, for example?
Or like write another diagram, you mean? Like
Yeah,
specific to this deployment?
exactly.
Mm-hmm.
So we can put the IP, public IPs, and maybe if we change ports, we put them here, and we can figure out in the future, maybe we will forget about it.
Yeah. So I think we can add another slide to this architecture deck only. So this is a high level thing, so it doesn't assume a lot
Yeah,
of things. So for example, it just says this API, but in actuality, this is a service of type load balancer if you have deployed it in Kubernetes. But since it says Docker or Kubernetes, so it's not specific to a platform on which this is deployed. So I know what your concern is, and I think we can have another slide where we can expand this thing specific to Kubernetes so that there we can move around with stuff. So I think, yeah, the first task is to have another slide which can detail the how the topology looks like, right, for Meshery and its deployments. So so to your point, the only service of type load balancer would be of Meshery, which the clients communicate to. All the adapters also have a deployment and a service. It's a standard deployment service thing for all of these for Meshery as well as Meshery adapters. The service of type load balancer will only be for Meshery because that's
yeah.
the only thing that clients communicate to. All of them are just cluster IPs which are communicated to like via Meshery server.
Oh, yeah, okay.
Hey guys, what are we trying to deploy? The Meshery playground, right? What does the playground do?
Yeah.
Okay.
So
Okay.
I get where you were going. So instead of using draw.io, what we can really use is mesh map only, the thing that we're trying to deploy to create the topology of and I could feel Lee trying to trying to force himself to the conversation just to point out we have a tool for this. That's what we're building right now. So instead of we can build a design over here and collaborate on that design so for example, it would be easier to explain that thing if I went into like here or search for a deployment. I could have searched, but I scrolled. So anyways, so I give like we can drag and drop deployments and services and group them into node groups and draw edges between them. So I will draw a topology here and then we can collaborate on this topology so that we're on the same page over here instead of draw.io. And since all the designs are public right now, so if you were to log in and if I were to change this to, let's say, Meshery Playground, you would be able to see this thing. So yeah, you would be able to change these things as well.
And actually, Ashish, to your point, just as just to prove your point, any of you that are on the call and have access to the currently deployed Meshery playground, you should be able to go in and actively, if you go back for a second, Ashish, to that design, just to make sure. So yeah, so you can, even better than draw.io, well, even better than its native support, you can actively collaborate. So yeah, it's a little bit of horse before the cart, or like this is a designer for Kubernetes workload deployments, and that's what we're discussing. And so, yeah, we should try to use the thing to deploy itself if we can. That'd be really, I mean, it's like, well, wait a second. Well, what are we doing here? Yeah, okay. So that'll be great. That'll be really interesting. It doesn't mean, yeah, it'd be really interesting because, you know, yep. I mean, there's a lot of nice benefits to that. So there's a lot of use of Equinix servers, these bare metal servers that we're discussing. There's a lot of use that the Meshery project and the Service Mesh Performance project, a lot of use that they, excuse me, that they make of these servers today. There's a GitHub action that runs on schedule like every 12 hours or 4 hours or something. It goes over and spins up about 12 bare metal servers, installs Meshery, Meshery installs a service mesh, Meshery generates a bunch of load, it analyzes that load, takes that those performance test results and persists them. And then the GitHub action deprovisions all those bare metal systems. So this community has already created an automated deployment of Meshery, which is this Meshery playground is a deployment of Meshery. It's already creating provisioning bare metal systems. It's already deprovisioning them. We should go look at that because in order to get there quickly, we should be taking a similar approach. We've already overcome some of these challenges. The approach that's within, oh man, this is awesome. How many people do we have collaborating? It's awesome. The approach that is used within the existing GitHub action is to, like I said, provision bare metal servers. When it does, it installs Minikube. It's like, that's not what we desire for this deployment. We want it to be Kubernetes on the metal. Having said that, it's still a great template or still a good thing to understand. It deals with how do you run a GitHub action on github.com and have it remotely connect to and provision servers in a different data center. Like it already overcomes a few of these challenges. So using it as the boilerplate makes a lot of sense to me. What do you all think? Yeah, and there's a link to that. Oh yeah, and so this is the action here that Ashish is sharing. So there's a link to that action in the Zoom chat now.
I've been looking for the specific workflow, but it's there's a couple that run scheduled benchmark tests, right? Do we want the self-hosted one? Like, is that part of the requirement?
Yeah.
Is that irrelevant?
Yeah. So this is the work. So yeah, this is the workflow here. The Ashish.
SMP action.
Yeah. And there's a couple of bash scripts. I think one.
Oh, okay.
And it's installing Minikube. It's like, well, that would work. That's not what we're really going for. For a number of reasons, we don't want to necessarily do that. Mm-hmm. And yes, this particular action runs on schedule. It's invoked in GitHub's cloud, or, wherever they're running on Kubernetes, wherever they're running those actions. But it is credentialed to reach into the Equinix data center and spin up machines and spin them down. It's having a little bit of problem and its own problem, but yeah. So if we can, we should, because we have about 20 minutes left, I think that we're at a point by which we can break down a couple of tasks see if there are folks that might be working on those particular areas. I'll propose that we identify those tasks as an update to the issue description, so the issue that was opened. There are a couple of tasks in there now. Does anybody, a la of what we've discussed, is there a particular item that you have in your mind that you might want to and be able to dig into? Maybe it's the load balancing of the service.
Yeah, I would love to work on the load balancer service.
Nice. I'm updating the notes of the thing right now. As a matter of fact,
Okay, so I'll send out the kube config to you, Allah, and and I'll also send out to you the SSH keys so that you can log into the servers. And for networking, I think the first thing that you can do is like start Metal LB provision. And Lee, do we like? I think we should be giving access to the dashboard, right? This particular dashboard to people who would be contributing. They would need the access here.
Yep. We will. We have Allah's number. We will hunt him down and kill him if he does something intentionally naughty. If he does something accident, yeah.
No,
If he does
don't
something, if you accidentally break it and stuff, like that's a totally different. That's totally fine, right? If you
yeah, really.
Yeah, it is actually. It is.
Do we
Later
have
on.
talking about accidentally breaking things, do we have a backup plan?
Yeah, nope. Other than the automation, like the script, like other than like when we're done with this, that at the end of it, there should be automation that supports deleting like deprovisioning the full metal server and provisioning a new one. In part, like the backup plan is sort of implicit to the fact that it's automated. But no, actually, that's a good. I mean, to your point, like. That's part of what needs to be articulated in the tasks is, how.
I mean, like
So,
we should have at some point we should have some persistent volumes and storage maybe on the project. So for that part particularly, we can do like just a cron job just to send the data daily on somewhere else.
Yeah, I'm writing this down. So a monitoring plan, and there's a few facets to how to do that monitoring.
So another thing that you can do is that you can go over this particular blog post and figure out how much of this is scriptable. So this is everything after you have your servers running. And most of these things are like just bash scripts. Most of these things are. So all you would need to do inside of those workflows is to SSH into one of these servers, actually both of them, and then do line by line whatever this thing says. So if you conversion of this whole everything that this blog post says inside into a bash script basically, and appending to, so this ends with like this blog post ends at where you have a running cluster. Add more stuff to it like deploying. So our workflow will go even further to first of all, I will note down that caveat of what needs to be done. Otherwise, if you'll just follow this blog post in the Equinox deployment, there is a caveat. So I'll add that caveat. So that caveat plus this thing will get you a cluster, and then in the script further deploying Meshery and deploying Metal LB. So that's the next step. And then if we have a static public IP, that should be good, so that we can hard code that or pass that as an environment variable into the script. So if we have a IP there, we can create a Metal LB configuration, which would again be deployed using kubectl or anything after we have SSH. We can. So yeah, that would be part of the whole script. So you can go over this blog post and see if you can convert this thing into a script and how feasible that thing is according to you. I'll make sure I'll take the responsibility of adding the Metal LB and public IP thing. or if you want to do it, you can do it. So I think, yeah.
Okay, just I think I created an account here in this Equinix. So if you Google my no, if you search my email, you should find me here. Maybe on the organization you can add.
Oh, what's your name? I mean, I know what your name is. What's your name here?
I will write it down on the chat.
I don't know how much fine-grained how much fine-grained permissions are there inside of this thing. So if we can give people access to, because there is a global SSH key that I'm using, which can be used across any of the servers. So I guess we can generate an. So, okay, I guess I don't need to search over here. There might be some other place where I need to search. I don't know. I think this global search is for stuff within the org.
Yeah, within the organization there is at the in the project and team. Yeah, organization, and below it we have project and team.
Oh, maybe I'm not seeing it. Where is team?
Click on the project itself.
I am on the project. I'm on the service mesh performance project right now.
There is no select the project. What if you go onto the organization?
Yeah, I don't know if we can add people from here.
Yeah, it also is the case that there are this particular user that is signed in may not have permission to do that.
Yeah, that's right. Because in my test organization, I have the option here to payment methods, billing, and team, and so on.
Yeah, so we have that. I'm taking it down as a follow-up task though too. Initially, it could be that SSH credentials or kube config or what have you will get you going, but we should get you into here as well. So
okay,
there's a task for Lee. Okay, so continuing to just refine the tasks and get them allocated so that we'll close out the call in about 12 minutes. Ala, what's your, and if there's Ala, what's your GitHub user handle?
it's my email ID. Okay,
got you. And there it is. If there are other people on the call that wanted to actively pick up a task, now is the time to raise your hand. Otherwise, we'll just list the tasks and the issues.
Hey, hi, Lee and Ashish, Harsh this side. So I was just seeing we have to provision some Kubernetes clusters, right? So I just had one input, why aren't we using tools like Ansible to do so? Because these tools will make it easy to provision the cluster, configure and get the kubeconfig file of the current or the provision cluster which we require.
Sounds good. That's a great question. I think it's well, for my part, it's based on. That's exactly why you're here. It's based on ignorance of what is really easy within the Equinix environment, and I'm going to write that down as a task. Like I don't know. They have Tinkerbell. Is that what we should be using? There's lots of tenants that Equinix has that that have this same use case. So we don't need to go custom write it. Like, what can we quickly and easily use? Did you know, Harsh?
Yeah, like if you want, I can create some Ansible scripts that will do the work, like create a cluster with 2 nodes.
Yeah, or yes, although I'll rephrase that and say what would be really helpful to start with is to understand how we don't have to write our own Ansible scripts. Like what is already available for us to leverage off the shelf.
Okay.
and then maybe write those scripts depending upon.
Actually, yeah, I wanted to suggest that using Ansible, they do have this Equinix metal collection. So it looks like it's really declarative. It's not like we have to redo the wheel. But ideally, I'm going over the 10-minute thing for Kubernetes. Like all of these commands, they could be once we provision the 2 metal servers from Equinix, we could just use those targets and just run these arbitrary commands. Or like the idea is it's something that is declarative and that it's kind of like helps us replicate those prerequisites for the Kubernetes clusters to that we want to provision, right?
Yep. So there's, just to clarify, there's a CLI from Equinix. The CLI is called Metal. And so, yeah, so Mario's pointing out, like, you can programmatically interact with the Equinix API using Metal, the CLI. And Harsh, and Mario, like, part of that action item that I'm writing down is to do a quick assessment of the potential use of the Metal CLI and how far it goes. Does it stop at just provisioning the Metal system, installing the OS, and and where would we continue into provisioning of Kubernetes? And what does Equinix have off the shelf? Like, there should be a myriad of either Ansible or whatever tool there is to do most of what we're looking to do. So I'm just updating, trying to take notes in that. So I'm gonna share this real fast, maybe, so we can sort of land the plane and be done on this call. That is, and I'll need help with this because this is not complete. Does anybody know how to enable others to? It'd be nice if there are multiple of you that can update this list. And I think you have to be a member of the org, and then maybe.
I think you have to be the one who created the issue, right? Or is that...
No, like you here, if you go to it right now, I think Mario, you should be able to edit it, Mario.
Oh yeah, there is an edit button on the title. Let me see if I can. Oh yeah, I can edit the. Yep. So perhaps being a member.
Yeah.
The org.
So here's what we've got thus far. We've got to use the existing GitHub action as a boilerplate for the ability to schedule, like a 24-hour schedule to reset. Sort of the initiator and the thing that keeps the schedule is probably this GitHub action. What the action uses, whether it's Metal CLI or Ansible, or is probably a research item. And if I'm saying anything that people disagree with, don't hesitate. One, two, three, four.
Mm-hmm.
we create a bash script to initialize the class. So kind of before that, there needs to be this consider what to use to actually provision it. Ashish has pointed out the blog post that has a sequence of, it's about 6 things to just copy and paste in, I think. If that's the way we go. So Harsh, Harsh, what's your GitHub username? Or Harsh, did you want to take?
It's yeah, sure. My GitHub username is Harsh-Del. It's a little bit old, but it's there.
Gotcha.
Harsh-Del. Yeah.
Nice. All right. I'll say playbook, sort of hinting toward Ansible, but just existing. Yeah, you know.
Okay.
Anyway, if we start to write all of this out, it's like, and provision, deploy Meshery, and but so basically part of what we need to do is have a document about the various concerns when you go to deploy Meshery. So Meshery as a project is in need of additional documentation around how do you do an air-gapped deployment, or what are the considerations of a production deployment for Meshery? And so this, like an artifacts that we're going to produce from this effort will hopefully be put into Meshery docs. Because if you go look at the instructions on how to deploy to various systems today, they only take you as far as kind of getting Meshery initially stood up in a given environment. So one task is to have an entry for Equinix in here. Another task is to have a document that how to deploy Meshery to production document. So I'm trying to.
I have a question. So this is going to be a 2-node deployment, right?
Yeah.
So is it 2 master nodes?
Yeah, that ideally part of what has been described is that I don't know about that specific. I don't know. Maybe it should or shouldn't be, or maybe we should have 3 nodes. Maybe that it might be overkill. I do know that of what's been asked thus far is to give the master node, or the control plane node, the ability to schedule workloads to itself. But then your question is another good one.
Yeah, because so there's 2 servers. I guess one could be the master and also have like a worker node process running. I'm not sure if that's the right term, because one is a physical infrastructure, right? And the other thing is the Kubernetes node is just software running on each of them, right? Yeah, I'm going over joining the host in the Kubernetes in 10 minutes. So it looks like this there's some instructions for the master and others for the other nodes. But yeah, I guess one could be the master and also have workloads in there, and the other just workloads, like not a non-master one.
Yeah, it's just about the taint of the master node.
Mm-hmm.
We change it, we could schedule.
Yeah, because we want to high availability, right? So I'm not sure if can there be more than one master? I guess I'm not sure about that, to be honest.
Yeah, but in our case we have, and I think it's ideal to in this case, in a 2-node cluster, we have tainted the master, so we can deploy on that as well. So we have one control plane and actually 2 data plane, because one of the master is also a data plane. So
Also, we don't care if the master is down, like we wouldn't be able to.
no, I mean, we do care if the master is down, because the cluster would be unreachable. But in our case, I think in a 2-node cluster, having like
Two
one
masters.
as a master is one master is enough. If we
It's
go to a
okay.
3-node cluster, yeah, I mean, if you go into a 3-node, 4-node, it depends. I mean, like this is the 0th step in the first or second step in the next. Like once we have the thing going on, depending upon how much user requests there are, I mean, we can obviously upgrade.
Of course. Sounds good.
So let's make, so one of the action items that I'll take is to make sure that Harsh and Ala and Mario already confirmed, but that those that are participating have the ability to edit the description, so that at least we can fully identify everything that needs to be done. Some of this, maybe people might want to create new issues, new child issues from, if this is an epic, that would work just fine. It might be that as you work through a particular item that you decide to create another issue, you might just link back what that issue is here. So this can be a master list of okay, good. And so we don't all need to sit here and watch lead type. So the other thing is about getting people credentialed up or getting them access to the system. Right now, it's a 2-node. The idea is that it's a 2-node cluster. Maybe that's really silly, and it needs to be 4 really small nodes or 3 medium nodes, or whatever. But there's a bunch of considerations, a lot of considerations about like just the health of Meshery deployment itself. Does there need to be, are there certain dependencies in terms of the order by which these things spin up? If we have Meshery adapters, do those have to come subsequent to the server? And a lot of that is known already, but perhaps not written down. The answer to that one, by the way, is no. The adapters can come up first before the server. Adapters dynamically try to connect to Meshery server. Meshery adapters try to connect to Meshery server. They will sit there and retry for a little while. They will attempt, they'll stop, they'll back off and wait a while and come back, and they'll do that. Anyway, that type of thing needs to be, we need to make sure that we've got it written down and that we're considering that in context of a Kubernetes deployment. There's a, wait a second, is there, how do you deploy Meshery today? Should we script over Meshery CTL? I think that's how the existing workflow does it, I believe. That would work.
Yeah.
Or use the Meshery Helm chart, which might make sense in terms of enhancing the Meshery Helm chart with things like a liveness probe or whatever the other considerations are. So as a third phase to all this, like eventually it would be really great if one instance of Meshery is able to take that mesh map design and provision the playground. So. What else? Anything else the top of mind for people that we're not capturing just yet?
I have a question. Just the mesh map. I tried to add it in my hosted Meshery as an extension, but asked me to subscribe, and I don't know how to access the mesh map.
Oh yeah.
Do you have the mesh map role? Like, have you signed up for it?
Yeah, I did.
And he's been approved as of 20 minutes ago, just real recently. And so Ashish, do you want to answer that question? Like,
Yeah, you can log back in if you have the role now, you would be able to see mesh map instead of the sign up form.
Ala, do you mind, if you don't mind, maybe sharing your web browser? Just because if it is at all confusing to you, then maybe that flow by which people, request access and they're given access, maybe we've kind of got it wrong. So maybe we need to change how that flow works. Yeah, you're muted. Oh, yeah, you lost your right Zoom.
Right, I should unmute, I guess, before I start sharing. Okay, now you can hear me and you can see my screen.
Right.
Yeah, so I installed here Meshery in localhost with Docker, and I tried to access this one, this mesh map with the extensions. I clicked on sign up, then I'm lost. Like I filled the form here, then it's like I connected the cluster, and they want. It's like I would like to draw something as you are doing in the mesh map. And how can I request access here? And I fill this form, this one.
Like, can you try logging out?
Sorry, go ahead.
Log
Can you
out
try
from
logging
the.
out and log out and log in once?
It's with a Meshery provider. The
Okay.
non-provider doesn't give
Gotcha.
you those kinds of
Okay,
capabilities.
so I should select the Meshery Pro. Yeah.
Yes. Then you just
Yep.
off.
Got it.
GitHub's faster, but
Yeah,
or
yeah,
Google.
Yep. I think I did it before, but
Oh, it already exists, so
already have an
you need
account.
to.
Yeah. Okay,
use your
okay, no
email.
problem. Now I
Although,
can.
wait a sec. Shouldn't that be kind of?
What?
We can talk
Where?
about that. Yeah, just the enhancement of, like maybe a user would like to bind their email account with their GitHub, but yeah, not today. Let's not talk about that today, please.
Okay, no problem. Okay, thanks, guys. I got it. I will set up my account.
Yeah, yeah. So at risk of boring everybody, like this is actually a really important thing, Ala, that there's a lot of people when they see the playground, they're pretty intrigued. People sign up pretty fast. As a matter of fact, they sign up so fast that, that some of the resources on one of the systems that process that kind of run out of resource. And it's so awesome. Let's get it into their hands. But when we do, you're an intelligent individual, and it's confusing. The current flow is a little bit confusing in terms of like, great, you signed up, you waited patiently, you received an email that said access granted, hopefully. And for you were already you're running Meshery locally.
Yeah.
And you're like, okay, great. So you go back to Meshery and you're like, I don't see it. And, being a sophisticated user of software and writing software and all that stuff, you you might log out and log back in. Did you do that before just now, or can you, like, I'm trying to, can you walk me through? I know it sounds kind of silly, but it's
Yeah,
like,
okay, I got it. Like, I didn't receive an email about the access granted when I filled the form.
it would have been on this, like while you were on this call is when you would have received the email, because it's a,
Wait, I will walk you through the, like here, a minute. At this point, I'm trying to reset my password to access. Like, okay, I will share back my screen. It's like I was first hands-on on the Meshery on the Meshery platform. I logged in. A minute. Okay, then I now I'm facing another bug, I guess. I will just try another private browser. Okay, here at first I didn't select Meshery. I selected none. After that, I just go to extension, and here I figure out that I should sign up. Okay, I signed up. I filled this form here. I filled this form, I submitted. Then since I didn't receive anything in my mailbox, I thought it should be some time to someone get in and grant me access since it's a beta program. Then I waited a while and I tried to reset my password. You get me now, Lee? Like,
yeah. There's a couple of things that are, let me jump to the heart of, there's a couple of things that we might need to go change, but the heart of one of our issues is, what? You did not receive an email that says access granted.
Yeah, that's it. And like this first impression users, they will just go like I did. And for example, here I found another issue with the apps, configuration apps. Like you see this book info, it's the application that is figuring out in the documentation. If someone would like to do the first hands-on, I saw that in the documentation that just go and deploy the book info. But this here, it shows an issue regarding, wait a minute.
Do you have a?
Yeah, this one here.
Mhm.
This property, like, it's going in a loop. Here in the config file, you will see that the original one, it was correct, like without the spaces.
I'm going to execute. I'm
So
going to execute.
Yeah,
It's the
but if you
stable
deploy
build.
this one, it will tell you that it's not valid.
Mhm.
You see that?
But yeah.
what you see as a feature, it's a what you see as a bug, it's a feature. So you that if
You
not
want to
present,
be executed.
yeah, no, that if not present to you, it looks like if not present, but on backend, it actually is corrected properly. So that a prettified config is shown to you. So that what you see in the config necessarily does not correspond to what is given inside of what you would type in a kube config, because that thing is like designed for primarily for the mesh map client. So that's why there is a white spacing and all. But at
But
the time of deployment, if you do not go and manually change the config in any way, like you wouldn't run into that issue.
but
Yeah, but
wasn't but Allah is saying that that config was appearing twice.
yeah,
Is that correct? Once
Let me
without the
let me
spaces and another with the spaces. Can you?
with the spaces, the Cube API will respond and say like it will complain that the option is not valid, and this is correct. That there is no if not present with spaces in the.
Can you share the error like a bit
Yeah,
more?
yeah.
So it says invalid component configuration.
Right. If I put it back here, so
Then it works.
this way, it should this way it shouldn't work.
It shouldn't.
This way it should work. This way.
Yeah.
This, but the Kubernetes cluster will not accept this image pooling policy because it doesn't exist in the Kubernetes itself.
We do it. We change it to if not present. Correct. We change it to correct thing before deploying it to Kubernetes. It is not deployed as it is to Kubernetes. So even in the schema, you can see that it requires if space not space present. It doesn't require if not present.
Yeah, but here this it's this Meshery responding. But if I add spaces, so Meshery accepts the deployment, Kubernetes will refuse it since there is no.
So
Yeah,
both
because
have it an
this is not a
error.
Kubernetes. This is not a Kubernetes deployment. This is a Meshery design, and there is a difference between the two. Although they look exactly the same, we do a bunch of white spacing and prettification and all those things, due to which you cannot take a Kubernetes YAML and copy paste that stuff into a design and deploy it. And you cannot take a design and take a Kubernetes stuff and take it out of. And we do not guarantee these things because when we add functionality.
Sorry to interrupt, but then if you add the spaces back, it still fails, but because of Kubernetes not.
Yes, exactly.
No, it won't fail.
That's what I see. So
shouldn't
there is a
fail.
problem, right? Or not?
Yeah. Okay. I can.
Can you try again with the spaces?
Yeah.
Because at that point it's not a validation error from Meshery. It's Kubernetes not recognizing that pool.
I already posted the issue.
You posted the problem.
Yeah.
But okay, but can you add the spaces back? I think that's the point.
Yeah,
Like the spaces are correct for Meshery, but not for Kubernetes itself. I guess that's the real problem. Even though it's a confusion on the user side, like a user that is familiar with Kubernetes would try to remove them, thinking it's a problem. So that's kind of like, that's also like probably a UX thing, image pool. So you add them back.
What I did. I removed them.
And then you deploy it back once it's, I guess you need to look for it several places.
Okay.
So then you'll deploy, but then Kubernetes will complain because that's not something.
Yeah.
Let's see. So it is failing.
Yeah. So here, this response here from it's a JSON from the Kubernetes. You see?
Now this is a Kubernetes error, right? A kubectl.
Yeah.
Okay, that's a that's a bug. Can you take a screenshot of this thing?
Yeah,
and
sure.
Yeah, just take a screenshot of and file an issue if you haven't already. So the expected is having a space there, and the error you're getting here, this is a bug. So this needs to be addressed.
Okay, so should I just paste it here?
So a GitHub issue, I guess that's the.
I suggest creating that image.
Okay, okay. So can you walk me through it, please? Like there are a lot of components here. I would like to put it in the right place here in Meshery.
Yeah. This one.
It's
Okay. Issues.
General bug report.
General
perhaps.
Bug. Yeah. So it's image pool policy.
Image full.
Okay, guys, you can continue while I'm pasting stuff.
Matt, that was super important to me. That was really helpful. And had you not shared your screen and kind of walked through it, it wouldn't have been as obvious that we have two UX issues that are maybe more frustrating than the potential bugs, like you not getting an acceptance email just yet. It might be a time-based thing, so it might still yet show up, because in part that's the way the email system that we're using works. So anyway, there's like so we need to go consider some UX around the providers and why does it matter if you're choosing one, or how it matters. There's
What is hosted email? Is it hosted somewhere? Where I mean, where is hosted the?
Oh, the email and stuff. There is yeah. When you fill in a form to sign up for Playground or Meshmap access, which are quite similar, the Playground uses half of what Meshmap does. So when you sign up, that sign up request goes to Meshery Cloud, and there's just a request queue. And so while we were on this call, I recognized the name, accept, or grant access, which either does one of two things. It either just Meshery Cloud just sends the email directly. It just uses a service account, a Gmail account that's just a service account, or it tags you in MailChimp, like a free MailChimp account, just to help with like who all is receiving what emails and when, and the way that we interact with MailChimp, it usually takes like between about 15 minutes or so before the person would receive the email, and 15 minutes is already gone and already passed by. Pranav owns figuring this out. Is MailChimp even? I don't think in this. I don't know. It may be. Yeah. So anyway, Pranav owns that to figure it out, and he can report back in Slack or what have you. Then we've got this UX around none and what that means when you choose none. I think that probably the answer there is where it says sign up for Meshmap, it probably needs to
be disabled, or
yeah, well, one is
some tooltip saying why it's disabled as well. Like
yeah. Well, it's kind of this weird thing of like, if you're using none, it would be appropriate to show you sign up because we don't know who you are and maybe you don't have access to it, or maybe you don't know about it. So it should be shown to you. But
then it's a loophole because extensions will never change because we don't know who he is at runtime. So it's kind of like,
so we can put in, I mean, like, even if we, in the message right there, it said, oh, as you sign up, make sure that you sign into blah, blah, blah. I know that I wouldn't read it because I'm a lazy user and I just click the button. Like I saw a sign up button, so I just click the button. I don't read the rest of the crap. I just see an image. I'm like, oh, I like that. And then I sign up and then, and so, oh no. So we have to think
maybe
about
a state change. Now that's some other UX sharing like what he needs to do if he wants to use those extensions. Like a flag or something.
Yeah. But it's just rat holes because what if he turned off his Meshery server? He came back tomorrow. Hey, did they grant me access yet? And he signs in to see it. Like, it's like, well, he would just be another anonymous user. So how do we it's a challenge.
Mm-hmm.
The book info bug, Ashish is going to work through, but then there's a UX concern around, again, a user sees a bunch of YAML, looks like Kubernetes to me, looks like Kubernetes to everybody else. Like, we don't make it, we need to make it really clear what that is and if what you can do to it or what you should do to it. And then, I think that's all the concerns that Ala had. Like, so Ala, just to get you going now, if the email address that you used to sign up for the Playground, if you use that same email address to sign in, that user,
I should see the mesh map.
yeah, exactly. So, and if you don't, please be really vocal about it, because I mean that. And Pranav here, and Yash and Sudhanshu and Mario, and like almost all the people on here have administrative control to Meshery Cloud to go make sure that your user has access. Harkarat. Gosh, are you trying it now? Because I'm like really curious if it doesn't work. Oh yeah, you're muted. So Anu and Harsh, we should make sure that you guys have access to MeshMap as well. So Harsh, do you I think you unmuted, but I didn't hear you say anything.
Yeah, I'm just checking if I have access to that or not.
Okay.
Yeah.
Nice. Probably not strictly necessary for the for the other item, but you might enjoy MeshMap.
Yeah.
Anu, how about for you in terms of access to MeshMap? Oh, okay, you think you have it already. You'll check again. Okay. Well, great. I have a couple of tasks just to tidy up some of the action items and to make sure that people have credentials, people can edit the issue. And Ashish was saying, hey, our next touch point in terms of a synchronous discussion on this topic would be this coming Wednesday at the Meshery development call. So so no doubt this will be a topic there. But otherwise, we can just advance the progression through Slack and through GitHub until we talk again on Wednesday. Or using the mailing list if you want to. But we might want to use the developers at meshery.io mailing list. I think some of the people on the other mailing list may be sensitive to email that they weren't used to, email traffic they weren't used to. Wonderful. Very nice to see you all. Ala, you will let us know if you don't see MeshMap. Because we're gonna, yeah. Nice to see you all. I will post this recording onto the GitHub issue and let other people know that we're interested, that they can come check it out. And it's nice to have a couple of new friends. Harsh, Anu, maybe Ala. I don't know. The guy needs some more white in his beard. I'm not really sure what to think of him just yet. But all right, I'm out of here. No more bad jokes. Thank you all. See you guys later.
Thanks, bye.
I have access to.
Oh,
I
you
have
do?
access. Yeah.
Perfect. Awesome. All right. See you guys.